We'd like, if possible, to be aware when our data sets have outliers. As we've seen, they can affect our numerical summaries. Also, sometimes an outlier indicates an error in measurement or sampling. So maybe you sampled someone that wasn't in the group you intended to be sampling from, or you just got a wrong measurement. So an outlier can give you a clue as to data values that maybe you should be suspicious of and check on. And in those cases, you would correct them or you would not use those data values in your research. But outliers do not always indicate an error. So we don't just see something's an outlier and throw it out and not consider it. It takes some investigating to decide what to do with it. So how do we determine whether a data value is an outlier? Well, there's some different methods. Not everyone agrees on what constitutes an outlier, but the two methods I'm going to mention are pretty standard. Method 1 we've already seen. Back in section 1.4 in example 8, we said if a data value is more than 2.5 standard deviations from the mean, it may be considered an outlier. So you might want to go back and look at that example. The method I'm going to cover now uses our quartiles and our IQR. So it uses the IQR, the interquartile range, and something called fences. So first of all, you need to know Q1, Q3, and that interquartile range. And then here's what the fences are. The lower fence is Q1 minus 1.5 times that interquartile range. And the upper fence is Q3 plus 1.5 IQR. Once you've found the fences, the rule is that if a data value is less than the lower fence or greater than the upper fence, it is an outlier. In other words, a data value is an outlier if it's more than 1.5 IQRs outside the middle 50% of the data set. So let's see an example of finding outliers. The following data set represents collision coverage claims in dollars from a random sample of 18 claims. And here are the numbers. I probably don't need to read them off. We need to determine the quartiles so that we can determine the interquartile range, and then we'll find the fences. At that point, we'll be able to answer the question, are any values outliers? Now, I went ahead and put the data in numerical order to make this task a little less tedious. There's 18 claims, so I'm going to have 9 claims below the median and 9 above. So our median will be right between, halfway between 1657 and 1953. So median, and remember we also call that Q2. That will be the average of 1657 and 1953 to find the number that's halfway between them. That works out to be $1,805, $1,805. Now we need to find Q1 and Q3. So looking at Q1, there's 9 numbers in this lower half of the data. That's an odd number of numbers, yay. So the Q1 is just going to be the one that's right in the middle. So let's see, that'll be 2, 3, 4, 5. That should be this one. Yes, and similarly, Q3 will be the number that's in the middle of the upper half of the data set. So let's see, that should be 1, 2, 3, 4, 5. That should be this one. Yes, 4 above and 4 below that. Okay, so we have our Q1 and Q3. Q1 is 735. Q3 is 4668. Our interquartile range is defined as Q3 minus Q1. So that's 4,668 minus 735, which turns out to be $3,933. So now we're ready for the fences. The lower fence is Q1 minus 1.5 times the interquartile range. So for us, that's 735 minus 1.5 times 3,933. And that works out to actually be a negative number. It's negative 5164.5. So we're not going to have any outliers down in the lower end because there's not a positive number that can be less than a negative number. But let's look at the upper fence. Maybe we'll have some outliers on the upper end. So the upper fence is Q3 plus 1.5 times the interquartile range, which is 4,668 plus 1.5 times our 3,933, and that works out to be 10,567 and 50 cents. So do we have any data values larger than that? Yes, there is one. This one that wouldn't fit on the line. 21,147. That's an outlier. I'm going to leave you with a problem to do that's very similar to the example I just did for you. I've given you a data set and I went ahead and put them in ascending order, so it won't be too hard to find the quartiles, find the interquartile range and the fences, and then decide if any values are outliers. So please do that before you watch the next video, and I'll go over this with you in the next video. See you then.